Welcome back to our next video talking about the detection engineering workflow. Before we get into the nitty-gritty of the steps, I did want to talk about the input-output of detection engineering at a high level. And this can look very different depending on the businesses, how mature the detection engineering program is. But if we think of it as work comes in, work gets processed, and work goes out, that's a good way of looking at detection engineering. So as input sources, just as some examples here, we have hunting, intel, and response, like we talked about previously. And then we also have detection engineering themselves. So there might be various initiatives, how detection engineering might do their own tests and their own alerting. And we also have here business units, which can refer to really anything that I haven't covered. I didn't want to just put 20 different items on this input section. So let's say there's a vulnerability management team, a pen testing team, red teaming, various external parties, new log sources, all that kind of fun stuff. Going down one step to processing, we have testing, which we'll get into more in a couple slides here. The actual alert creation process, alert tuning. Sometimes alerts don't always work how they're expected in the initial alert creation process. So there's some tuning that needs to be done. Documentation, and then knowledge transfer. So when an alert gets made, what happens with that alert? Who needs to know about it? Then going down another step, we have output. So we have a detection document. No matter what SIM you have or how you're handling the whole alert creation process, there should be a finalized document on some level, whether that's a YAML file or a wiki article. And we'll get more into that in the future. Alerts for incident response. That's the main output for detection engineering. We also might have gap identification. As you go through the alert creation process, you might notice how security tools don't cover what you think they cover, or maybe how they're not configured properly in certain environments. And to the next step here, we have metrics, which is very important for management to tell the story on the department, what's getting worked on, what techniques are being covered, and we'll dig more into that in the future. 3 main points here for each of these steps. For the input can be from a variety of different sources, from both within the defensive teams we've already talked about, offensive teams, which we glossed over a little bit, and then other business units. For processing, similar to IR, detection engineering involves a repeatable step-by-step process. And as an output, I want to reemphasize again that incident response is the main customer of the detection engineering team, if we want to talk about it in that way. All right, moving on to the actual detection engineering workflow. This might look very different depending on the organization or business and how that department is structured. But at a very high level, these are some steps that you can follow and should align pretty closely with whatever engineering department in the organization that, let's say, you work at or you're applying for. This is roundabout how they should be operating here. We have information gathering as the first step, which is gathering requirements, making sure everything is correct in the ticket. And then we go down to unit testing, which involves maybe some more purple teaming or offensive testing, making sure the alerts that are being developed trigger properly and that we can have a repeatable test to make sure the alerts are working as expected. And then we go down to the alert development step, which is the actual meat and potatoes of detection engineering, where we're running searches, we're looking at data, we're making sure that any enrichment that needs to happen is done. Going down to documentation creation, we're going to wrap all that in a nice bow with a nice written document detailing out different metrics, let's say MITRE, which we'll dig into later, the certs themselves, the different names where the alert came from, and potentially any links that the incident response team could use. And then we have a peer review and handover. This could also be separated out into 2 steps. So there could also be a internal peer review within the detection engineering department, making sure that all the bases are covered, and then a handover to incident response or whoever really is going to be the recipient of the alert. Maybe you're making an alert for vulnerability management or a business unit. These 5 steps are what you'll see in different kind of organizations. Some steps might be flip-flopped. For example, you might have alert development and then unit testing where you're applying to, but this should give you a lot of good talking points in an interview or just talking detection engineering as a whole. Again, detection engineering is a repeatable step-by-step process. This is very important because good processes create good output. All right, going into each of these 5 steps individually, we have information gathering. This is where all the initial requirements are determined. So we have here if the request has the necessary information provided. For example, if you're relying on a certain new log source, you'll need information for that log source, documentation, even point of contacts that might be important for the initial requirements, slideshows that were presented based off of the initiative that you're helping out with. It could also be, let's say, from a hunting team, and that hunt team has a report that you can reference with some links. Going back to that initial slide showing the input of detection engineering, each of those little blocks could have a different expectation for the requirements that are coming down the pipeline. New log sources, we just talked about in that spiel I just had there. Is the data accessible? Does it exist in the SIM? Does the vendor have any documentation? Those are all really good questions to ask. And then prioritization, that's a big one. Depending on your detection engineering workforce, you might have more inputs than output. And by that, you might have some workforce restraints on how much work can be done in any given amount of time. In that case, you're going to need to prioritize what tickets get completed quicker. This could be for, let's say it's a new log source that's getting onboarded, it's getting rushed. You might need to pick up that ticket quicker than a log source that's going to be done, let's say 4 or 6 months from now, something along those lines. The goal there is the ticket ready to be worked? All right, next up, we have unit testing. This is a process by which we can review a log source. We can perform some kind of test. Let's say we have a test virtual machine, or let's say you have something in the cloud and you're going to run, let's say something on the command line or a program or a script, something that creates data that goes into the SIM that you can review to then determine if your alert logic that you're creating works as expected. Why is this important? We have 4 main reasons here. So number 1, confirms the alert logic. Number 2, it's a repeatable process. So if you have an alert that's, let's say, a year old, you have a unit test to run against to make sure that the data is still good. Let's say field names didn't change, data wasn't added that you can then put into the alert logic. Identification and tool validation go kind of hand in hand. This is a really big one. So for example, let's say you're not doing unit testing in your environment and you're creating searches to make detections. That might mean that you're writing searches on hypotheticals for something that hasn't happened in your environment yet. And that is ultimately an assumption. Without a unit test, you don't know if the logging is visible, if the tool blocks the activity you're attempting to do, and ultimately if your alert logic works. Next step is alert development. So we have an example here of a step-by-step process, developing an alert starting large and getting more detailed as we go. So you'll have an initial query that it's very broad. You're looking for anything involving the activity that you're looking into. Then you can have a refinement stage where you narrow down that focus, maybe look at a single source, maybe do a little bit of digging into what fields are available. There might also be an enrichment step. This essentially means that you're plugging in information outside of the log that's currently available. That could be information in a different log. That could be an automation step where you have a plugin in your SIM, for example, analyze a URL, pull back if it's a no malicious domain, run some checks against file hashes to see if they're malicious. This can all be done in the SIM through an enrichment process. And then a finalization step where you roll all that together, you have it as refined and enriched as possible. And that ultimately is going to be the detection that you're going to hand over here. The example below, we have a rough pseudocode example here. So we're looking at any source, any data source in the environment, and we're looking for somethingbad.com. Okay. And then we realize in our unit testing and the use case we're looking into, we care about email. So we're looking just at email. And then we want to look at more than just one domain. We want to look at any malicious domains that we care about. So we can have a lookup table that has all the URLs that are bad. And we can say, okay, look at all the emails and then look up the URL field in this bad URL list. Okay, so let's say we have 10 URLs that we care about. We can have one query that will trigger on those 10 URLs. And then for the enrichment step, given a URL or domain, are there any network hits in our environment? So just because an email was sent to one of our employees doesn't necessarily mean that they hit the link and got infected. What we can do is have some kind of subsearch or lookup by which that URL is looked at in, let's say, our proxy logs, really any kind of firewall that has that kind of north-south visibility. And then rolling that up, we can say, all right, we can finalize this. This is good. Source is email. We're looking for URL contained in a bad URL list where network traffic has been observed. So we've gone from looking at just somethingbad.com across any data sources, and now we're looking at something very specific that's actionable for the incident response team. Okay, so for example, if the network traffic didn't exist, that might not be something we want to get sent to the incident response team if, let's say, their email security appliance is blocking these emails or dropping them or blocking the URL. We only want to see what's possibly infected. And that's just an example. And the main point here, you start off at a high level and you narrow as you go. All right, moving on to detection documentation. The two key pieces here is some concept of standardization and tool sets. So standardization really just means that you're following some kind of format or template that works for your environment. This can ultimately be determined by the SIEM you're using, or you can use a vendor agnostic tool like Sigma that converts a Sigma YAML template into the different vendor formats. There are some gaps with how that works, but ultimately that might be your best first step if you don't really know what SIEM you're going to use, or if you're planning on switching SIEMs, you can have a vendor agnostic way to store all your alerting. Or if you're pretty in-depth into one of the Splunks or the Elastics, ArcSights, whatever vendor that you're going with, if you're pretty deep in that ecosystem and it's serving your needs and you don't expect to move, you could use the vendor format. That might be a good route too. It'll help you speak more directly to the vendor if there are any issues and things of that nature. So Splunk uses a YAML format and Elastic uses a TOML. We can go more into that later in this course. Or if you're a glutton for punishment, you could write your own custom format and have conversions to send that to the different SIEMs that you're using. Moving over to the tool set, you're going to want to store all your detection documentation somewhere, whether that's GitHub, GitLab, Azure DevOps. There's 1.5 million CI/CD pipeline tools. You're going to want somewhere where you can write Python or have it accessible via some programmatic means. I did put a couple links in here. We have uncoder.io, which helps you convert from different formats. So if you get, let's say, a Splunk alert, but you have Elastic, you can put that Splunk syntax into Uncoder and then click a button and it'll spit out an Elasticsearch for you, which is really handy. And then SOC Prime, that might be something you want to go down if, let's say, you're shorter on resources or you don't have the capabilities to spin something up by hand. It's a paid service ultimately. There are some free options, but to get all our features, it's a paid service for corporate use, and it has a bunch of features baked in to help detection engineering. They create alerts for you. They also crowdsource alerts, and that might help you get started maybe a little bit quicker. Ultimate point here, detection documentation needs to be standardized, enforced, and searchable. Last but not least, we have the peer review and handover process. Okay, so how does this look? We have a detection engineering peer review here, followed by an incident response handover, followed by documentation uploaded to the SIEM or to, let's say, a GitHub, which then pushes the alert to the SIEM. You have the alert confirmed that it's enabled, and then you can close out your ticket. A lot of this might sound pretty self-explanatory, and really it is. But ultimately, the final alert is properly validated and acknowledged by both the detection engineering and incident response teams.